Okay, I think today only a few people joined. So good evening, everyone. Welcome to the second live session for the course Functional and Conceptual Design. My name is Neelarnab Dutta. I'm a PMRF fellow and a PhD scholar from Department of Design, IIT Guwahati. And the agenda for this class is to help you with your assignments. So, have you finished your assignments? So the deadline is tomorrow, 10th of August, for the week 2 assignments. So I want this class a bit interactive. So please use the message box for any query and to reply to my questions.
Not failed it.
Okay.
Fail it.
So in this class, since the nature of the assignments are objective, I will give a brief overview of important concepts that you need to have a knowledge to solve the assignments. Okay. Okay. So you might have gone through week 2 class videos. So have you gone through the videos? Okay. So what do you think is common among these companies? See, there is Samsung, Apple, Tesla, and Hyundai. So what do you find common among them? The very first thing is that they are all product based company. Okay. So they are all product based company. And what product they make? Okay, so what is common like Samsung? You have Samsung refrigerator, you know.
Design phases.
Okay, no, I'm talking about what is common in terms of their products. So Samsung has refrigerator, Samsung has phone, you have smart TV, a lot of etc. Right? Similarly, Apple has phones. Okay, and then you have the PC, tablet. Now Tesla, I'll come next. So what do you think is common between these two? You know, the common is that phone market is common to both of them. Okay, phone market and also the PC market. Phone market is common to both. They also have phone market. So which is common. Okay. So how they compete? Okay, how they compete in the market. So my question is how these companies compete in the market. If both have phones and PCs, how come they ensure that customers come to choose their products only? So what they do in terms of business strategy that enable them to stay in the market to remain competitive? Any answer?
New features.
Yes. So what they do, they always focus on improving their products. Okay. So in order to stay competitive, they focus on improving their product portfolio. And what is the nature of this improvement? If you see, just remember, like in 2011, we have Apple and Samsung competing. Apple has the iPhone 3, and Samsung come with the first Galaxy S. Okay, then in the mid of 2012, every year they come up with some new phones. Okay, because they want to capture market from each other. Okay, there's a market and they want to capture market. This is like the customer. So then they come to S2, then you have S3, then you have duos in between for different market segment. So they strategize to capture different market segment. For example, this is lower middle class, this is like higher class people, who can afford price, and they cannot afford. Okay, they cannot afford. But iPhone, like, come up with iPhone 4. It is even more expensive than iPhone 3, then iPhone 5, then 6. If you see in terms of specification, they are almost equal. However, iPhone always focus on the the higher paying customers. However, Samsung tried to capture both the markets, the lower as well as the middle. And because of that, what changes they need to create? So for example, this is Samsung and this is Apple. Okay, so to remain competitive, they have to bring new features into their phones. So they need to come with new features. Now, in order to achieve these features, they need to improve their processors. Okay, their touch sensitivity. Then you have cameras. Apple also come into the same game, saying that okay, I'm also improving my phone, which has a GPU inbuilt. So they used MediaTek processor at that time that has a GPU enabled. Okay, then they also have cameras. So slowly the processors come from MediaTek for both. Okay, then both adopted similar configuration in terms of processor. Okay, then they move to cameras. Okay, now they are using two cameras, three cameras. Okay, and like now Samsung is coming up with curved display. Sorry. Okay, so Samsung is coming up with curved display. Okay, so all of these they do, okay, to remain competitive. Okay, and who is responsible for all of these? I mean, like, you have all sort of changes to remain competitive in the market. See, someone has to work on cameras, someone has to work on touch sensitivity, someone has to develop new processors, and okay, someone has to work on software. Okay, both, like Apple also come up with their iOS software, Samsung has their Android version, so they also have to version of new softwares like Android versions, vanilla ice cream, and now the latest ones. So they are constantly improving their product. Okay, and who are these people? Okay, do you know the answer?
Come up again, please.
Pardon?
What was the question?
See, like we have companies like Samsung, Apple, okay, and to
Mm-hmm.
remain competitive, they constantly improve their phone features. Like Apple come up
Correct.
with new GPUs. Now features like Samsung come up with curved display. Then they have
Mm-hmm.
modified Android. They come up with new features. Now they are playing with cameras. Now there is not one camera, they are using 4 5 cameras in all together. Similarly, companies from China like Vivo, they are playing with selfie camera. So what is this? All are trying to improve their product portfolios, okay, and want to stay competitive. But who is the you know frontline troops who is responsible for all these changes?
Designer.
Uh, Basically, the requirement from the market, and the requirement converts into the function. So that may be the driven factor over here.
Yes, that's a driven factor, but someone has to change those, right? So who are those? Okay. So answer is the product designers.
Mm.
So as a product designer, you need to take care of industrial design. In my last class, I mentioned like the different types of designs. Like one part is industrial design, another part is the engineering design. Okay, so there are different responsibilities. Some of the design changes come from industrial design perspective. Okay, so the nature of the designers also different. Similarly, some of the changes needs to be developed from the perspective of engineering development. Again, depending upon the nature of the requirements, the engineering profile can be changes. There are software developers, there can be like hardware designers. So all those together we call them as product designers. And now if you see the companies who are originally are not mainstream mobile phone makers, they are also coming into picture. Okay, so to stay in competitive, what Tesla is bringing? Tesla is saying like, I'm introducing a new network which is called Skynet. So they will have satellites all over the earth, which will have interlink, and this is some sort of private network. They are trying to engulf, they are trying to cover the entire geographies of earth, and people can use this particular Skynet, which is the name of the sorry which is the name of this particular network, and a user can directly use their phone as satellite phones. Skynet. Okay, so this is what Elon Musk is trying to come up with in his communication domain, telecommunication domain. And as a product, Tesla is bringing now a new phone which have the capability to connect with the satellite directly. So there is no requirement of towers. Like in Earth, we have towers because of the curvature of the Earth surface. You need multiple of these. Okay, so because of the curvature of the Earth, you need multiple of these to manage different geographical regions. However, what Elon Musk is trying, he is trying to build the network with the satellites, small satellites, and the users can subscribe the network and directly communicate and use the internet service through the satellite communication. Okay, so that's a new value proposition. Actually, this is like what we call, these are like value proposition. So as a designer, you also need to think about new value proposition. So it's a role of designers. That's why I'm saying, like, whether you are an industrial designer or a engineering designer from different domains, okay, all you need to do as a designer is bring new value proposition to the to stay competitive in the market. For your companies also, when you are working as a product manager, you are working as an engineer, all you need to bring new value propositions to stay in the market and to save your jobs also. Similarly, Hyundai in the past come up, like they used to have also phone market, and that was resistive one. And since they lacked the technology, you know, they could not capture the Indian market. However, still there are phones, in Korea, it's like India, they could not capture Indian market because the cost of manufacturing and cost of selling, they could not, manage to be profitable in India, because they are primarily are not semiconductor based company. However, Samsung had a chip manufacturing company, so it was easy for them, you know for to bring their product to the market. The problem with Apple was that Apple never had their own chips. They all manufacture their chips in China or via Samsung. Okay, means in Korea. That's why cost of their phones are a bit high. So in order to stay profitable, they targeted their customer profile, which can pay higher, premium. So they choose, high paying customer segment, the rich one. Okay. However, Samsung have, the its own chip manufacturing plants, and it has all the engineering teams, so it is easy for them to acquire all sort of components and decide on whatever configuration is appropriate for smaller customer segment, like like middle class or low class peoples, and whatever is possible for high class. So those distinctions they could do because they have that capability to to bring conceptual design into reality. Okay. However, Apple did not have. Okay. So I hope this is clear here. So uh, the main aim for this discussion is that you have to understand the role of product designer, and you as a product designer play the frontline role in any product design company. Okay. So have you studied like week one lecture? So if you have gone through those lecture, there Professor Asokan has described the three types of product design. So can you identify those types of product design? So what are the types of product design? Any answer? Okay.
Original design where you are bringing new ideas or new intervention to the market and which directly influence the market and people.
Okay, you are right.
Another one is iterative design, but I'm recollecting it, where original idea will remain same, but certain what do you say, ki, technology will be changed to enhance the experience.
Okay.
Mm.
So I think
Yeah.
I need to clarify a few things here. So one is original design. The second category is adaptive design. Okay. And the third category is the variant design. So what you described as iterative design is variant design basically. So let me give this example here. A processor, when it was discovered, or not discovered, it was invented first time, like this changed the entire semiconductor industry. Okay, so earlier you used to have, like vacuum tube based devices like radios. Okay, then you used to have transistor technology. Okay, when transistor come, then vacuum tubes are gone, and then you have the transistor radio. Okay, now later people come up with solution, like a design solution, like how to integrate like thousands of, like millions of transistors into a small form factor, and you can do higher order processing. Okay, so what happened here is that there's a there became a new, application area, emergent application area, that actually people could thought about, which previously people could not come up with, because of this particular thing was not evolved in that time. So because of that, this is known as the original design. Okay, okay, so such kind of design. Now the design can be engineering design as well as industrial design. That's a different question. Okay, but whether it is a industrial design or, sorry, someone has, okay, so whether it is a original design or whether it's a engineering design or industrial design, it does not matter. But a original design is something which happened first time, and because of that particular design, new application areas of using that particular technology or design come into picture. So after that, what happened, like people realized that, okay, now we can have computers. Okay, there can be, people can thought of, like, because of chip, there can be like some other machine, like printer. There can be printer which also use this particular chipset. People can think about, uh, you know like phone, which also need this kind of microprocessor or processor. So because of that, using that, numerous products come into picture. So all these design are basically adaptive design. Okay, so adaptive design is basically when you adapt a known design, okay, and you use it for a new application. So what is adaptive design? Basically use existing design or technology and use for new application. Okay, so what is last one? The last one is basically a variant design. Variant design means you are not changing the new application, but you are changing the specification. Okay, so basically here you are not changing the application, the code application, basically like the computation. Like for example, for the difference between a laptop and a computer is that, like the desktop, is that they are all used for computation. Okay, that is the core basic requirement. However, you change the specification. Okay, for what? To achieve some new usability requirement or user requirement. Okay, so what are those? The specification change can be change of form, change of form. As you see, like this is now more portable. Okay, so you come up with a portable design without changing the display technology. Okay, this is the same display technology, but now you are integrating. Now you have the same keyboard, you are bringing it here. So changing the form, probably you can change uh, the mouse. The concept of mouse is like, here is like a, handle independent device. You bring it to here as a trackpad. Okay, so all this integration brings into change in specification. Specifications can be changed in like battery. Okay, it can be changed in processing power. Okay, so all these things, so all these kind of design, what we call is variant design. The name itself suggests the three types of design. One is original, okay, which means there is nothing before it, before this. Okay, then you have adaptive. That means you use the original design, and you have multiple adaptive. You can have many adaptive design. Okay, now adaptive design can be of like different products, like printer. Okay, you can have PC, like something else like a juicer. Okay, now within the printer, if you are now changing specification, these are variant design. Am I clear? Am I clear here?
Yes, yes.
Okay.
Yes, yes.
So can you tell me the difference? See, a product can evolve like this. You can see a design, like already told you, this is original, this is like the adaptive, and this is like a variation of this. Okay, what I said initially is like original design can have multiple application. So this is like application one. There can be other products also, but this application one, if this is a desktop, this is one variant of this. So variant of a PC. This is variant design, adaptive design, and original design. But what is this transformation in terms of design? So you have a original chip, like long time ago, the first chip like 8085, 86. Okay, then you have Pentium, 4, 5, then you have dual core, and now you have the Xenon processor. So can you distinguish, can you identify, if we know like these are the three kind of design, can we identify what this kind of design is?
Intel Xenon processor is a variant design.
And what
And I
about
think
dual core? Okay, so the question here one need to ask. Okay, so question here, this is very important. Okay, now it is very easy, right? It is very easy if you retrospectively go back and then historically try to see what is original, what is adaptive, what is variant. But today, being in 2022, you know can we design something original? Can we design something adaptive, in 2022? Okay, and can you
yes, we
design
can.
something variant? Okay, so what I mean is, like, how do you classify this three? Here you can see that No, you are using a particular component like this. If you say this is a product, you are using this product in multiple products. That's why you are saying this is original. Okay, there you see the dependency, because this is 19, 80s probably. This is like 2000, and now this is 2000, probably 10. Okay, so historically it is easy, to understand, like, okay, this is probably the original. But can you answer this particular question, like in today's timeline, how do you know when you want to design something and that product is original and this product is adaptive? Any answer? Okay, so let me give the answer. See, a original product is the source of the original product is knowledge, which is new. Okay, new knowledge, new technology. That means you come up with a new knowledge, new technology, and that's why you have an original product. A adaptive product, what drives adaptive product is synthesis. Synthesis of existing technology. Okay, and what drives a variant design is just a specification change. So specification change mainly drives variant design. Synthesis and analysis. So analysis and synthesis of original product, when you try to use that to for varying applications, you have the adaptive product. So when you have a new product, like in 2022, if you come across some product, you just need to check whether the knowledge, that is behind the development or the design of this particular product, is it new or old. If it is new, if it is something completely novel, then this is the original product. And if it is something like the core technology exists, but you figure out a different use of it and result in a varying application, then this is an adaptive product. Am I clear? Any question?
Hi, can I ask one thing? Like when I
Yeah.
talk about a smartphone or any other phone, it generally comes in each and every years. So what do you say? This is variant design or adaptive design? So every year Apple will be launching their new phone and
Okay.
Samsung will be launching their new phone, new smartphone basically talking.
Okay.
So their variation will be coming
Okay. So this is
11th
very
Gen, 12th Gen.
okay. So I'll give that answer by giving you one more information. Okay. So there is product and there is component. Okay. Okay. So it's very important. Okay. A component is also a product. Okay. But how you distinguish a product and a component? For example, if I say this particular chip is a product, yes, it's a product. Okay, but it can be a component to this particular product. Okay, this is when you consider this particular product, it's a component. So basically you have a product and there are multiple products which are dependent. These are dependent products. Okay, so these dependent products are now called components of this particular parent product. So this is parent, this is a child product. Now in the market, in the retail outlet, you may buy these, okay, as MRPs. Like those all have individual MRP. Okay, sometimes they may have their independent use, their standalone use. Sometimes they do not have their standalone use. For example, a processor itself does not have a standalone use. However, if you say, for example, a nut and bolt or a screwdriver, those components probably have a standalone use. Okay. Now, when we are talking about, to give your answer, like when we talk about a smartphone having so many dependent components, okay. Now things happen in both ways. In terms of, so for example, this is 2018, this is 2022. Okay. Now you have a processor here, you have a RAM, you have a camera. Here also you have a camera, you have a RAM, processor. This is like space. Now from here, this RAM to RAM, there can be a original design. Okay. From processor to processor, it can be a variant design. And if you see the overall product, it can be a variant design. So the relationship or a design that happens is always happen in an integrated way. Did I give you the answer? Did you understand?
Yes, yeah.
Okay.
Yeah.
So you need to first understand the hierarchy in which the products are like used. Is there any dependency? So there can be original design happens here. For example, like the Samsung come up with a new display, like which is curve display, flexible display. So yes, the original products, a original design happens at the display level, but overall design, no, it's same. You still have a phone which is used for communication. It has a smart display, touch based icons, all those are there, but it has component. One that component display, and now you have a original design. Okay, so things can happen at the macro level, at the component level. So those are also products, but they are product till they are not dependent on a higher order product, on a parent. Okay, so these things happen like in an integrated manner. So original design, adaptive design, and variant design happen simultaneously. A product, when a new products come into the market, there may be original designs within each component, there may be design adaptations, okay, and there can be also variations in terms of specifications. So all this happens simultaneously, and these may not happen simultaneously. There can be like smartphone have lot of features and lot of components. That's the reason why these things happen simultaneously. But if you see like a uh, like like a product having only one functionality or one component, so in those cases it doesn't happen. Like I gave you initially the example, like the safety pin, when it comes, okay, the design does not change after that. Okay, initially people used to tie rope, stitch with rope pin, but when it happens, it happens. So there are not multiple, it's like original design, and there is no simultaneous adaptive design or variant design happen. Yes, nowadays like you have different version of this paper clip. So what I mean to say that there can be products which have a one or two functions. So there only one kind of design may happen, and if it's a complex product having multiple product as components, so all these kind of products can happen simultaneously. Okay. Okay. Okay, so have you heard about the term redesign? So what is redesign then? So we have three kind of design, right? The original design. So we heard about the original. Then we have adaptive, and now we have the variant design. Then what is redesign? Can we answer? Have you heard like, okay, we need to redesign this? So what happened? Is it
After getting feedback from market or after getting feedback from users, if certain problem is coming, so we have to rethink on the technology and even rethink on the form as well. So
okay?
both way we can redesign the product.
Okay. So what do you mean by redesign is that the product exists, okay? The product exists. It's not something new, but the present, the design having certain shortfalls. Either it is not meeting customer requirements or it is not meeting the engineering requirements. It's failing at user testing. So there can be failure at testing, engineering design problem. There can be manufacturing issues. It's not easy to manufacture. Okay, so and it is not sustainable in terms of environmental safety. It's not safe. So all those shortfalls, all I say these are shortfalls or the limitations which when you try to overcome, you basically do a redesign. So redesign does not mean it's a new kind of design or new type of design. This means it can be a original design. If when you first come up with a chip in this particular configuration, you realize that this is not happening. It's not it's not working in the desired way. You change. So you come up with a new original design. Okay. So this is again a redesign. So redesign can be a original design. Redesign can be adaptive design. You thought like, okay, there can be a using this particular original design, I will make a PC, but the first PC you make having certain faults, so you redesign. Okay, you again have a PC. Similarly, in the variant design also, you change specification because previous specification is not suitable for some user, or you got certain complaint, so you changes the specification. So you have a very like there are faulty systems, there are customer complaints, then you come to know that after some market survey, then you redesign the original design, or not original design, the design itself. Okay. And also, while redesigning, you can think like, for example, if you are making a PC, you find like the the processor is not good enough, so probably you can also go to a original design. Think like your transistor based processors to something like a quantum computational processor. Okay. Similarly, things can happen even like when you feel like changing the specification will not work. You actually have to change the entire product itself. You do not need a laptop now with a similar configuration. You probably need a new product which is like a smartphone. and using this original design. Okay, that can also happen. So redesign can happen in any way. However, what does it mean is that the design which you are going to redesign have certain shortfalls, because of which you are going for a redesign. Okay, am I clear? Any question?
No, I think it's clear.
Okay.
It's clear.
Okay, so have you heard about these two terms, stage gate? Okay, did I miss anything here? Okay, first tell me this: what is the difference between these two particular design in terms of their processes? You have a 3D printer and you have a chair, and what do you think the difference between the approach in these two particular design? Any answer? Okay.
Yeah, 3D, like where you do the modeling and then entire thing will be processed by the computer, or I would say uh, generative design. And then this side will compare with the chair. So again, you will be doing all those design, and then obviously the specification you will be giving to the carpenter, and then they will be making accordingly.
Okay.
So,
So if
so
you
there is manual work. Yeah, other one is like completely computerized.
okay, so that's
So
the
error won't be there in computerized where like printing is going to happen. But in this side, maybe error happen at the certain joint or somewhere.
okay. Yes, you are right, partly. So basically, this is a wooden chair which can be made by a low skill person like a carpenter. Those are mostly and does not involve any technical background, or does not need the analysis before actually design. I mean, it needs some sort of analysis, but not like extensive as like the 3D printer. Why? Because the knowledge of designing a chair exists from a very long time, and now these informations are like common sense. Now these are common sense in terms of the cognitive thinking you need to do. It's different, like you do not have the hand-on skill to design this particular thing. However, in terms of synthesis and analysis, how to design this particular solution is a common knowledge in today's era. Okay, but if you think about a 3D printer, both the two products have different application. But if you compare, to develop a 3D printer, you need more skill. So you need more skill required, because the technical nature of this, and you need engineering, analysis, testing to perfect the product. Lot of computation involved, as you said. Okay. So because of this, when we do, okay, these kind of products which I am defining as engineering product design, it's better if you follow a systematic approach to design. Okay, so you follow a systematic process to design. Okay, so what is the benefit? Can you tell me? Now, what is systematic? I will tell you. Systematic means you are doing things systematically, one after another, one after another. And what is the benefit?
Avoid any mistake, any discrepancy in future.
Yes. So basically what you are doing, like you are making sure that each of the analysis and synthesis you are doing at a particular point is performed correctly. Okay, and then you are moving to the next task, and then you move to the next, and you then come up with a solution at the end. So since you did all these individual small steps in a perfect way systematically, you are making sure that your final product is free from any sort of error. Okay, so in relation to that particular concept, we have something called stage gate design process. So have you gone through the lectures, week 2 lecture? What is stage gate design process? Okay, stage gate design process is, it's more like a, you have a stage, stage means phase. Okay, then you have a checkpoint which you call as gate. Then you perform the next stage or phase, and then you again do a checklist, a checkpoint. Now these stages and checkpoints can vary, that I will let you know. Then you have stage 3. Okay, like that you keep on doing, and at the end, after a final checkpoint, you launch your product. Okay, so the benefit of this particular way of designing is that you are making sure that at every stage, actually, you are performing the task correctly at micro level, so that when at the end you reach, for your final product delivery or implementation, you come, you yourself will be sure that since I have done all these stages correctly, my product have achieved all the milestone and is now ready for commercial implementation. So that's what it's called, stage gate design process. So so those are benefits, but do you think any limitation of this particular process? Can you think about any limitation?
Limitation could be time taking, or not sure about like what will be the outcome.
Okay,
Skill
exactly.
level.
Like this process is a long process. It's time taking because you are not doing things in a parallel order. Second thing is, like, you do not know how your product will look like. Only it is possible to visualize your product when at the end of this particular timeline. This can be like a year long timeline. So visibility of the final product is not there, and also it consumes a lot of time. So those are the two main limitation of stage gate design process. So from the picture below, can you find the product here, like which can be designed using stage gate approach?
Fighter jet, I would say.
Yes. See, in fighter jet, you are correct. Like this is the example of Tejas. You have so many components, parts, and technologies that you need to develop, and the validation of this particular thing happens like stage by stage. Although there are better design processes for aircraft design, but for the sake of understanding these two topics, this particular topic, I am just explaining that things happen in a product like aircraft in stages, and there are checkpoints. For example, radar. You want to make sure you have a good radar system, like which can detect the enemy aircraft from a long distance. You want to make sure the airframe, maybe is it stealthy or not. You want to make that airframe stealthy. Okay. So the stealth design of the airframe can be one challenge, which actually you want to finish designing, and then only you can think about integrating the other components. Okay, so you are waiting the aircraft, the outer, the body design, till it is verified that you now have a stealthy airframe. Then only you can think about integrating the other parts. So this way of designing have dependencies. Unless this particular thing finishes, you cannot move here. And unless this particular stealth airframe got finalized, you cannot move to your weapon integration or other avionics. Okay, these are like avionics, weapon integration. So this is one of the design scenario where you can have stage gate design approach. Similarly, in automotive also, you do in a similar fashion. Like when you do a new product design, like new product for new automotive design, not like variant design, but a new product design. When you go for engine, okay, new engine, then you come up with new body. So basically, without the engine, you do not know how much, what's with a particular form to to enclose that particular engine. So after finalizing the engine, so before that also you need to come up with your requirement for power. So power requirement, then you design the engine. After designing, you know that how much space you need to provide to hold the engine, and then you come up with the rest of the body. So slowly then body design, then manufacturing, and at the end you launch the product. So this is again stage gate. There are checkpoints, at every stage. Okay, so have you heard about the other design process, spiral design process? So what is spiral design process? So spiral design is basically a multiple stage gates. When you require multiple stage gate to achieve final product, and at the end of each stage, sorry, stage gate process, you are selling your product or you are commercializing your product. The product. So what happens here? So you have a product, okay, but this product is not 100% refined. It is 40% refined. You have the next product, the product 2, which is probably 80% refined, and then you have product 3, which is 100% refined. There can be also like new features like product 4 with added features. So it is a new, like another product 100%, but still have a added features. So like that, what happens in designing every product, you have to follow a stage gate like this. And so this is the product. In order to reach the second phase, you need to go through multiple checkpoints and phases till you reach the next product. So these are like the checklist checkpoints, okay, like checkpoint 1, checkpoint 2, checkpoint 3, and these are like the phases. Similarly, from product, the second level product to the third level product, you also have another stages and checkpoints, okay. However, although you do not have a fine product each at the end of each stage gate, still you are able to sell your product, okay. So what kind of product is? Can you tell me from the picture below?
Windows.
Yes. So Windows, even SolidWorks, okay. See, these products are, you have a version every year, okay. So whenever a product launch date you finalize, like, okay, I have to launch the product in 2012, I have to launch a product in again 2013, okay. So whatever update I could achieve within this period from 2013 to 2014, that would be enough for a new launch. So in these kind of products, you use this kind of spiral design. Got it? So SolidWorks, for example, have a version like SolidWorks 2016, and you cannot wait for till the product reach the quality what you actually can have in 2022. Like, you cannot, it take lot of development time, and you do not have the vision also till you reach 2019. So every year you realize, you set a new vision for the product, and slowly you move toward perfection, okay. But the product every year have that level of quality that it can be commercialized also, okay. So the nature of such nature of product always follow a spiral design approach, okay. The limitations are that you never have a fine product at any year, okay. So the product development process is temporary in nature, okay. So you cannot use this particular format of design or approach of design, your aircraft design. You cannot release like 2012, I will release the aircraft without a rudder. Now in 2013, I will only use the stealth feature. So what will happen, like, you cannot actually fly your aircraft without having all those, without having 100% capability. So you cannot, have you cannot use spiral design approach in these kind of products. However, in mostly in softwares, you can use the spiral design approach. So what are the properties of spiral design approach? The one is like, you do not try to achieve 100% efficiency. And in fact, you do not know what is 100% efficiency. You always keep on improving. So it is always improving. You set your delivery. You set your delivery, which is time dependent. Okay. Am I clear here?
Yeah. Yeah. Perfect.
Okay. So this is the last phase of today's lecture. So what are the key stages in product design? So if you have gone through the lectures from week 2, you might came across like the various stages of product design. So what are the key stages?
Find the pain point of users.
Okay.
Is it needs?
Okay, let's write find a pain point. Okay, what next?
Find the technology which can solve that problem, that particular function. Technology, then form, and concept, then other thing, iterative design, and everything will come. But I'm not so sure because I've not gone through.
Okay,
Think like
so please go through the lectures because tomorrow is the deadline for assignments and I am trying to help you with your assignments. If you attend today's lecture also, you would be able to solve the assignments. Okay, the very important
okay.
phases are three. One is understand the opportunity. Okay, this is the first stage. The second stage is develop a concept, and the third stage is implement a concept. And as you said, like find pain point of user, all such activities, using all such activities you try to look for the opportunities. Okay, so this is not only one activity you do, these are like some of the activities if you do. This is what we call this need analysis. Okay, similarly there are activities like developing a vision. Then we have market opportunity analysis. Then competitive analysis. So using all sort of activities, lot of activities you perform here, and the goal of these activities is to understand the opportunity. Okay, and based on that you come up with certain requirements. Okay, based on which you design, you basically you enter the second stage. So this is again a stage gate approach. This is where the checkpoint, you have the checkpoint for the first stage, which is phase 1 or the stage 1. Checkpoint is like you can set your own checkpoints, like did we come up with competitive advantage, and can we capture this, like 50% of market share. Do you have a clear thought about the product, and what are the pain points? Is it a need driven project or is it going to be just a technology push product? So all those opportunity analysis you do at this particular point, and those can be a checklist. So you come up with here your requirements, and then you go to the next phase, which is stage 2, to develop a concept. So in the concept development phase, you basically come up with your conceptual design, which can be either engineering design or industrial design. Then you go for your functional modeling or functional architecture. Then you do your, you perform concept engineering. So all those things you do in stage 2, and at the end you do again some sort of checklist, checkpoint. So checkpoint again can vary. You can define like, is it feasible, is it feasible, like can we actually manufacture this particular concept. So that is the question, is it feasible to manufacture. So all those set of checkpoints you can use to enter, to go to the next checkpoint, next phase, which is stage 3. That is the implement the product. So implementing means two things. One, when you come up from a concept, you move to a, prototype. It depends like what is the quality of this particular prototype. Is it of manufacturable standard? Okay, in that case you need to perform activities like design for manufacturing, and if the concept has not been realized yet, you need to actually do your engineering analysis, and then you need to think about how to do make the prototype. Okay, so you can do simulation testing of your product. So all sort of activities you do, in the phase of implementing a concept. Okay, so at the end of implementing a concept, actually your design is ready for commercialization. So now it is ready for commercialization. So these are mainly the three key stages of product development, and they are mainly three. First is to understand the opportunity, second is to develop a concept, and the third is to implement the concept. Okay, so let me give an example. So this is a work, my past work in the field of product design. So imagine, so I'm just giving you as an example, not as a case study. So just try to figure it out, and try to make you understand what happens and what things, what activities actually one need to do in this particular phase. So the first phase is, understand the opportunity. So the problem here is that, like, you may have came across buttons based remote controls, like we have the TV remotes having lot of, buttons, but every setup box have their, own set of numbers assigned to the channels. If you use Tata Sky, 102 will be GTV, or for example 104 is Sony, and 105 is like Discovery. But if you, take another setup box from Airtel, now you will have different numbers, 506 probably, 806. So for the user it is not very easy to memorize all these numbers, and going to the menu, big menu, and then selecting your channel is only possible when you have a smart TV. Without a smart TV you cannot actually, uh, with the setup box menu system also you can go, but again that is a tedious process. Okay, so the question is like, can we come up with a solution, something like we speak the channel name and the channel triggers. Okay, so that is the problem you realized. So what do you mean by that? That means you have a vision, okay, of a problem, So this is like what you are guessing as a problem. Okay, but is it a real problem? You do not know. But based on your experience as a designer, you say, okay, users may face this particular issue. There are a lot of buttons they need to navigate. So let's make it simple and come up with a solution which is like, you can have like few buttons and speak the channel name and it will just trigger. So that is the designer vision. Okay, the next set of activities that you perform to understand the opportunity is go to the customer. Okay, you can meet your families, your friends, or you can go to the field and ask people if they face this similar situation. Okay, you can have a interview. So there are different techniques how you do a contextual inquiry. There can be interview, there can be survey, there can be just a discussion. Different ways you can perform to gather this information. After that you understood that, okay, really this sort of need exists, then you see, or straight from your design, when you have this particular vision, you can actually go for your market opportunity. You can check, is there any solution similar to your concepts, like what you are thinking, like does there exist similar ideas in the marketplace with the similar to the vision you have. Okay, so you find out in that phase the different products that can be used in a similar fashion like what you have envisioned. Okay, so these again let you to understand what is the competitive price, what sort of competitive value proposition they are providing. So you need to understand now value proposition, feature, price. Okay, again market opportunity also include like how much market capture you can have to make this particular device profitable. Okay, so profitability you check when you check market opportunity. Okay, so this is the stage actually where you do all these sort of activities. Okay, now then you do a check. Okay, you do a check. What you check here? You check these particular questions. Is there any opportunity? Do you think like do the customers or the users face similar issue, and do they want to buy such a device? So those can be a checkpoint. And then like can this product be profitable? Okay, and can we propose something new in terms of value proposition? So all those checkpoint filters you can use to proceed to the next stage. And during this particular phase or checkpoint, if you face like, okay, there is no requirement, there is no customer requirement, there is no market opportunity, or there is no competitive need, then you stop the concept development here. However, if you think like you have a clear vision, clear market opportunity, clear customer segment, and clear better value proposition, then you move to the second stage, which is to develop the concepts. So what starts in the development phase? You can go for conceptual development first. How it will be like, this is now the job of an industrial designer, and this is what we call industrial design. So this is UI design. Okay, where the designer come up with a interface, button based interface, like how to navigate across various menus and channels. Okay? And where will be the mic. Okay, so all these are at this stage conceptual level, and then you do detailed functional modeling, which is like you try to understand what things needs to go inside. Okay, so you have a mic, so there is a voice recognition module. Okay, then there is some sort of control logic, and that trigger the IR signal. So you need to basically map your voice across various channels. So there can be different technology you can adopt. You can go for natural language based processing. You can go for uh, fixed what is called speech recognition modules used for only voice recognition, not speech recognition, only like single voice recognition, and you can map those voice against certain channel number. Okay, and then you trigger that IR signal to your setup box, and the setup box then control these as channels. Okay, so this is basically what you do as a functional modeling as well as product architecture. Then you do concept engineering, where you actually go to engineering detail and try to understand how these particular concepts can be made feasible, in a particular form factor. Will it be possible, like how the buttons will be? So this come into picture as CAD CAM. Okay, so once you finish these activities, then you go to the next stage. But before that, you need to again go through a checkpoint. So here what you check basically different thing. You can check like whether the concept feasible. Okay, so that is an important question, like, do you have the budget, have to budget to design this? Because you already fixed your design and then you said like, okay, this is very expensive, does not work comparing the existing button based design, so we should not go for making a new product. So you can stop again here. But if you think like, okay, I'm happy with these checkpoints, I can go to the next level, then you can go, and actually you can go to the implementation level phase. Basically in the implementation phase, as I told you, you actually develop the product uh, embodiment. You do the detailed engineering detailing, how different components will go inside. You do PCB design, you go for uh, button design, you plan the various materials that will be used, so how power will be provided. All these decisions you make at the implementation phase, and you then come up with hardware and you do testing. So these sort of activities, you carry on generally in the implementation phase. And so once you did your testing correctly, you can actually move for commercialization. So again, you can have a checkpoint at the end, like do the device satisfy the bench testing outcome? So that can be a checkpoint, and actually then you can go ahead for commercialization. Okay, so that's is an example for explaining you the three stages in a more visual way. So any question?
No, no, as per now.
Okay. Okay, so thank you. So that's the end of today's session, and the next session will be on week 3 lectures. It will be again held in next Tuesday, same time. So please be present and please go through week 3 lecture videos before coming to the class. Okay, and if you have any query, please contact me at this particular number. You can WhatsApp me for any sort of queries. Okay.
Yeah, sure.
Okay, thank you.
Thank you so much.
Bye.
2050, right?
2050.
Bye. Thank you.
Okay. So I leave here. All the best for your assignment. Tomorrow is the deadline. So please finish it on time.